Okay, sorry, this also says equal to 0. We're going over solving quadratic equations. Now they want you to find the roots. What they mean by the roots are, sometimes they call them zeros or x-intercepts. They're talking about when this quadratic is a quadratic, right, because we have x squared. We know some parabola facing up because the a value is technically 1 here. Remember, we have our, when I mean a value, I mean the a value in our standard form. So here's our standard form. Ax squared plus bx plus c. Okay. And our a value here is essentially just the number 1. So it's positive. So we have some parabola like that. What we want to find is when it crosses the x-intercepts. Okay? And in other words, normally this is also equal to, we won't put 0. This is usually f at x or y, right? And in this part, what they've done is they've set f at x or y equal to 0. So what they're talking about is when we're on a graph, our y-axis is 0. And the y-axis is 0 along this point here. Okay? So that's exactly our roots then. We're going to be looking for the x-intercept. So we need a factor in order to do this. So we find the factors of the first term, which is 1x squared, and the factors of that are 1x and 1x. And we look for the factors of the last term, 4. We have 1 and 4 and 2 and 2. And we know that what we're going to try to do here, oh, I know I can box these. That's a good idea. We're going to set these up in columns. Okay? So we have our columns here, and we're going to multiply the columns by each other, either straight across or crisscross, and the products need to add up to, after we multiply, our b term, which is 5x. So we're going to test these out. Just to go through it, I'm going to go with the other two first. 1x times 2 would give us 2x, and 1x times 2 would give us 2x. Any combination of 2x and 2x get us 5? No, so that won't work. And if we crisscross, is it going to be any different? No. So we know the 2x won't work. Okay? And if let's go straight across. 1 times 1x gives us 1x, and 1x times 4 gives us 4x. Any combination of those make 5x? Yeah, if we add them, right? So we multiply across and we get 1x and 4x. And if they're both positive, they work, right? So in other words, both of these numbers are going to need to be positive. So now what we have is these are our first column, or our first terms, and we know these are our second terms. And what I mean by that is when we go to put them into our brackets here, we're going to have, these will be our first terms, and the second column will represent our second terms. So we're going to plug them into these spots. So in the first terms, we have 1x and 1x, or just x. So I'm going to put x and x. And in the second one, we have positive 1 and positive 4. Now, because these are the same, it doesn't make a difference. But say this had been 2x, we'd have to put them in opposite columns. So if I put the 2x here and multiply by positive 1, 2x would be here, positive 1 would have to go in the opposite column. Now, because the first terms are the same, it makes no difference. So we're just going to put positive 1 in this one and positive 4 in this one here. So there's our factored form. It's equal to 0. Okay. Let's zoom in. So we know that's equal to 0. Now what we got to do is, this technically means multiplication, right? And in order to create a 0 through multiplying, one of these has to be a 0. It's the only way it works. Can't multiply by another number and get 0. So I'm going to set each column equal to 0. X plus 1 equals 0. And x plus 4 equals 0. Okay. Then we're going to solve. I move the 1 over, so x can either be negative 1 or x could either be negative 4. And what that means is our x-intercepts are at negative 1 and 0, that's our y, and negative 4 and 0. But your roots, essentially, these would be your answers. X is negative 4 and x is negative. Alright, this is another example. The only difference is this one's not a normal trinomial. Like we said before, we were used to the ax squared plus bx plus c. And that's our f at x, correct? We're used to it like this, trinomial. But this one only has two terms, it's a binomial here. Oh, I wrote the c already. Okay. But this is called a difference difference by subtraction, that's how we know what it means by difference, of squares. And what that means is I can square root both the first and the last term. So if this is possible, if I can find a even or an integer for a square root, not looking for decimals, a square root of an even number or a whole number, like 25 or 64, and there's a subtraction sign, it's called a difference of squares. So what you do is you find the square root of the first term and you find the square root of the second term separately. Okay, so we'll do a little side calculation over here. Square root of 25x squared. Do you know what that would be?
Just
5x. And square root of 64. Yeah, that's right. Now technically it's plus or minus 5x and plus or minus 8, but in this case we just want the absolute value of the numbers, okay? When we go to put these into our brackets, we set it up again into two brackets. And same idea, the square root of the first term are going to be our first terms, and the square root of the second term are going to be our second terms in each bracket. Okay, so we're going to have 5x and 5x, and we're going to have 8 and 8. Now, the only difference here is what's in between. The operation is just going to be a plus in one and a subtraction sign in the other. Okay, and then from there, we would split the equations, set them both equal to 0. So we get 0 is equal to 5x plus 8. 0 is equal to 5x minus 8. Bring the 8 over, we have negative 8 equals 5x, and positive 8 equals 5x. And finally, negative 8 over 5 is equal to x, and positive 8 over 5 is equal to x. And those would be our two roots. Okay, the positive and the negative version. Okay, again, we're trying to find roots. This is A, B, and C, right? This is our f at x. So we're in standard form, as you can see, plus bx plus c. We're in our standard form, and we have our terms, negative 9 for C, negative 4 for B, and 1 for A. So we go to factor this. Factors the first term, permanently here. That equals 0. Factors the first term are 1x, 1x. Factors the last term are 1, 9, 3, and 3. And we know that their product needs to add up to negative 4x, right? So let's quickly go through this. This gives us 1 and 9. Is that going to work? No. If we go across, no difference, right? 3 and 3, is that going to work? And if we go across, will it work? Okay. So we kind of run into something here. Factoring won't give us a whole number. So we use something else called the quadratic formula. So what this is x is equal to, in other words, they're going to solve our roots. X, and we have to make sure it's set equal to 0 when we do this, is equal to, and we get our quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac divided by 2a. Have you seen this before? Okay. And yeah, I did. What we'll do is we'll just color code these so that we can kind of relate them to what we're doing before. So that's our b number, our b, our A, and our C. So the reason we color coded it is because we're going to be taking these values here and plugging them into this formula to figure out what x is. So as we extend the page here, and we'll zoom back in a second, what we're going to get is negative plus or minus, and I'll plug the numbers in after, b squared minus 4 times, and then divided by 2. Well, our b term is negative 4, right? So it's negative 4, negative 4 squared. Our a term is 1, and our c term is negative 9. So let's zoom back in. We're going to go equate this now. So what's negative 4? Yeah, so we have positive 4 plus or minus the square root was negative 4 squared. That's not 8. Yes, that's right. So positive 16 minus, well, negative 4 times 1 times negative 9. Yeah, good. All divided by what number? 2. 2 times minus 2. We go inside those brackets, plus or minus the root of 36 and 16. Good. 2. Okay. Now we're going to bring up a calculator here, just so we know. 52 square root is 7.2111. We'll put that as that, okay? So, this is where it gets tricky. 4 plus or minus 7.21231 divided by 2. Now, they tell us plus or minus because the square root of 52 is technically plus 70 or 7.111 and negative 7.2111, right? Because when I multiply both by each other, they will both give me 52. So at this point, we need to split this. We're going to get two answers, just like we do when we're factoring, right? It's a parabola shape, so we're probably going to get two roots. So I have to equate x is equal to, and that's what we were working with before, 4 plus 7.2111. And what I'll do is I'll just put this in another color so that you notice one version is plus divided by 2. And the other one is x is equal to 1. 4 minus 7.2111 divided by 2. Okay, so we have two separate answers we can solve here. So in this version, we're going to get x is equal to 11.2111 divided by 2, whatever this number is going to be, and this one's going to give us negative 3.2111 divided by 2. I'll figure out what these two numbers are. Plus 4 divided by 2. And they said the two decimal places. So we'll round, I guess, up. 5.61 is one of the answers. 5.61. And the other answer, we had 4 subtract 7.2111 divided by 2. 1.61. Sorry, negative 1.61. X is equal to negative 1.61. So these are our x-intercepts, right? Not all parabolas are going to go through at whole numbers. Probably it's more likely that we have something like this. So if we were to graph it, you could say these are our roots or our x-intercepts of that equation. Okay. Now because we couldn't factor it, we had to use the quadratic formula, which is very important. We got to remember to use that one in order to find the roots. Okay, this question talks about, it's a word problem. It says the water balloon is catapulted into the air from the top of the building. Height is represented by h of t, and t is time. The flight is represented by this function. Now, this function's in standard form, so I'm not going to write the letters out, but that's negative 5 is our A, positive 30 is B, and our C is 10. The very first question here asks us, what is the domain and range? So we know we're going to have some parabola, okay, and because A is a negative number, that parabola is going to face downwards, okay? And which means the range is going to be from the vertex downwards, and now, technically, if we were doing it of the entire function, the domain would just be XER. It would go on forever. But because we're talking about a specific water balloon, we have t, time on the x-axis, and we have height on the y-axis, okay? Because we can't catapult a balloon from before we launch it, like in the negative values, the domain is actually going to start on the y-axis, or when x is 0, and then it's going to stop because the balloon obviously doesn't go flying through the ground of the Earth, right? It stops when it hits the ground. So the domain is actually going to be from the y-intercept, or of course 0 for x, to whatever the x-intercept is. Okay. So we need to figure out the range and the domain. Well, to figure out the range, we need to find out the vertex of this. So what we're going to do is put this into vertex form. And to put it into vertex form, we would complete the square. Okay, so negative 5t squared plus 30t plus 10. So we've done this before, so I'm going to kind of go through it quickly. Completing the square, remember we take our a value and we divide the first two terms by our a value. Our a value in this case is negative 5. So we're going to divide both of these by negative 5. And then negative 5 comes to the outside of the brackets. Is equal to, we'll have t squared minus 6t plus 10. Now remember, we do some side calculations from here. Oops. When we do side calculations, I'm taking my 6 or my negative 6, whichever you want to call it. Remember, it's b divided by 2 squared. And there could be more to it, but I'm going to go through it this way step by step. Okay, so now we get negative 6 divided by 2 squared is going to give me negative 3 squared, which gives me 9. So I got to add plus and negative 9 inside the brackets because we're creating a 0. So we have negative 5 t squared minus 6t, and then we add and subtract 9 inside the brackets, plus 10. Well, we only need the positive 1 inside the brackets, so I got to move the negative 9 out, and in order to do that, it has to be multiplied by my a value when it comes outside. You recall this?
Yeah.
So negative 5 t squared minus 6t plus 9, and negative 9 times 5? Now, remember, the whole reason I did this is so that this becomes a perfect square trinomial. In other words, I can square root the first and the last term to figure out what's going to be in one bracket. So one bracket will represent square root of t squared. Yeah, square root of 9. Yeah, exactly. So we have 3. Oops. 3 is the second term. We have t and 3. And what goes in between them? How come positive? What's there? Yeah, because that's a negative. The negative comes down. Okay? And then we put a squared out here because really this represents what we've really done here is we factored this, and we've got actually t minus 3 times t minus 3, but we just represent it like this, so it's in vertex form. And then we equate what's on the outside. Negative 45 plus 10 is negative 35. So this is in our vertex form, and if you remember vertex form, f of x is equal to ax minus h squared plus k. I'll write them in. Again, our a is still the exact same as in when we're in standard form. H represents the x value of the vertex, and k represents the y value of the vertex. So our actual vertex, we'll do it in red, is positive 3 and negative 35. Sorry, I knew there was something way off there. This was negative 5. We should have multiplied by negative 5, which would have made this positive 45. Does that make sense? Back up here. When we brought the negative 9 out, this was negative 5. I only multiplied by positive 5. I should have multiplied by negative 5. So negative 9 times negative 5 is positive 45. So this should not be negative 35, but should be what number? That was just a small error I made. And the reason I knew that was wrong, so this should be 55, is because it told me I should have a y value that is negative. So in other words, we would have shot the balloon below the Earth and through the Earth and down. That would have made no sense. So that's why I knew there's no way that my vertex could be a negative number. So I took a quick look, and I found my mistake. I forgot to multiply by a negative number. So positive 55. So that's the highest point. So what that said is after 3 seconds, the balloon was 55 meters in the air, 3 and 55. Okay? So in other words, our range there, of our 3 and our 55, the range of this function is, we're looking for, the highest point is 55, so range is y is every real number, right? Such that y is a less than and equal to 55. Okay? So less than and equal to 55. So that's what our range of our function is. And the domain, well, the domain, I got to find out what the x-intercept is. Okay? I got to find out what the x-intercept is. And there's a couple ways we can do this. Okay? One of the ways we're going to do this is we're going to use what we still have. The x-intercept is when y is equal to 0. So we're going to take our function, which we discovered it here. This is in our vertex form, and we're going to go with it in vertex form here. So this vertex form here, when the height is 0 is when it hits the ground. So we're actually going to set this equal to 0. Okay? We're going to set this equal to 0. So I'm going to do it below. What we're going to get is 0 is equal to negative 5 t minus 3 2 squared plus 55. So we're solving when the height is 0. Reverse bed mass. So I'm bringing over negative, or I bring 55 over, I get negative 55. T minus 3 squared. I'm then going to divide by negative 5, both sides. Does that make sense? 11 equals t minus 3 squared. Now to move the squared over, what do I do? Square root 11. So I'm going to get a funny number here. Well, not funny, but a decimal. 3.316 we'll call it. So we get plus or minus 3.316. Remember, square root is a plus or minus answer. Is equal to t minus 3. Okay? And when I bring that 3 over, I have plus or minus 3.316 plus 3, right? Equals t. Well, because I have a plus or a minus, I'm going to get two answers here. So let's do one with plus, positive 3.316 plus 3 equals t. We'll do another one with negative 3.316 plus 3 equals t. Right? If it's a parabola, we're going to have two x-intercepts. So this one becomes 6.316 equals t. That's when it hits the ground. Or negative 0.316 equals t. Well, let's think about this. Negative. Can the balloon have hit the ground before we even shot it? No. So this represents seconds. So 0.3 seconds before we shot it, the balloon was not in the ground. But 6.316 seconds after, the balloon's hitting the ground. So what it did is it solved the other x-intercept, which remember we said we'd have two, but that one's not logical because before negative 0.316, we don't measure before the balloon is shot. The balloon is shot here. So it hits the ground after 6.316 seconds. So our range is then from 0 to 6.316. So we then put, well, our domain, sorry, not our range. Our domain is x is every real number such that x is between 0 and 6.316. That's when it hits the ground again. So, a lot of things we did for just two small questions. Oh, sorry, one small question. We actually only solved the domain and range there. Okay? Okay, last thing we need to go over is when will the balloon reach the height of 30 meters? Okay, we're going to jump to the other page here. Now, we have the original function, which is our height was equal to negative 5t squared plus 30t plus 10, right? Well, when is h at t going to be 30? Well, we just plug 30 in for h at t. So 30 is equal to negative 5t squared plus 30t plus 10. Well, in order to do this, we need, remember, if we're going to factor things, we need this side of the equation to be 0. So I got to move 30 over. When I move 30 over, 0 is equal to negative 5t squared plus 30t plus 10 minus 30. We're going to equate that part. Negative 20. And now I have something that I can either, maybe I can factor it, or I put it in the quadratic equation, or I turn it into vertex form and solve. There's several different ways to do this. Okay? Now factoring might not work, but the first thing we'd probably try to do is factor. If that doesn't work, we use maybe quadratic equation. That will work. There we go. Equation. And finally, instead of maybe using quadratic equation, what we just previously did on the other page, we complete the square, put it in vertex form, and then solve for t. So there's really two major ways to solve this. These are both the same. You either factor or you do the quadratic equation. And the other way we could have done it is to put it into vertex form.